Good morning, everyone. Well, you may be watching this in the afternoon or the evening, but nonetheless, here we are. So, we are going to go over what, in the experimental process, what variables and control groups are and how they function and how we use them in science. So, as you can see, a variable is a factor or part of an experiment that differs by amount. Experiments often have three variables. One of those is the controlled group or the control variable, the independent variable, and the dependent variable. And we're going to look at what each one of those means, and again, some examples of those. So the independent variable, by definition, is the variable that's changed by the scientist. So this is what you're doing to something that you're testing on or testing about. A good experiment only has one variable, and that's actually harder than you think. And then, as you can see there, as the scientist changes the independent variable, the scientist makes observations about what happens and collects the data. So the data is what's important from this, because this is how we draw conclusions, is based on this data that we collect. So that's always one of the most important things that we can do is accurately collect our data. So the dependent variable is the variable that you measure in an experiment. So it responds to or depends on the independent variable. So that data we just mentioned, that would be one measurable way to determine the dependent variable. So as mentioned earlier, we also have the controlled variable, the variables that scientists want to remain constant and controlled in the experiment so that he or she can better observe the dependent variable. So this is something that you would want to keep in its normal function, normal activity. You don't want it to be different than what it would normally be. So that way you have an accurate comparison. And again, we're going to look at some examples of these. So a lack of sleep can make you gain weight. What's the independent variable? What's being changed there? So we're going to assume that you normally get enough sleep. And so in this case, the thing that's changed is now you're getting a lack of sleep. So the independent variable would be a lack of sleep. And then what's changing, or what's the result, is another way to think about that. And that would be our dependent variable. And in this scenario, gaining weight would be our dependent variable. Tomato plants grown with music have more tomatoes. What's the independent variable here? Take a second and see if you can identify the independent variable. If you guessed the music, you're correct. So the thing that's changed there is people don't normally play music to their tomato plants, right? And so that would be a thing that's being changed from the norm or the normal to try to see if it has a result. And again, take a second here and think to yourself, or say it out loud, however you prefer. What is the dependent variable here? If you guessed them having more tomatoes, you are correct, because that would be the result of playing the music. So the cause is the independent variable, and the effect is the dependent variable. Let's look at another example here just to get a good feel for everything. Fish oil in your diet will improve your memory. Again, what's the cause? If you said fish oil, that's correct. And what's the effect? If you said the dependent variable was improving your memory, that's also correct. Trout raised in cold water weigh more than trout raised in warm water. You should be getting the feel for this by now. So what's the cause, or what's the independent variable? The cold water. And then what is the effect of that? They weigh more. Now, you could be more extensive in your answer on the independent variable. You could say cold water is better than warm water. But you don't really have to go through all that. You just have to say that the cold water is the thing that they're looking to alter or change, and then the effect of that is it causes them to weigh more. Walking 10,000 steps a day will lower blood pressure. So the independent variable, walking 10,000 steps, the effect, or the dependent variable is lowering your blood pressure. Hamsters raised on a taco diet have less heart disease than hamsters raised on Purina hamster chow. I do not recommend, just as a disclaimer, that you feed your hamsters tacos. And I don't know that Purina hamster chow is a thing, but let's go with it anyway. So the independent variable here is the diet, right, or the food that's being fed to them. So in this case, we're looking at a taco diet versus a Purina hamster chow diet. So here, we could say that it's the diet or the food that's being fed to the hamster, and then the effect is we're looking at having less heart disease. Eating lots of fruits and vegetables will make you a faster runner. Independent variable? If you guessed eating lots of fruits and vegetables, then you are correct. And what's the effect or the dependent variable? If you answered run faster, that's also correct. What would be an experimental group in this? I had to think about that one, didn't you? So the experimental group in this one would be the people who are actually eating the fruits and vegetables. And then if you had a control group, you would have people who eat, not necessarily less, but like an average amount of fruits and vegetables versus lots. So those aren't really quantifiable, meaning we don't really have a number to put on lots. It's just a very straightforward, simple example. And we already identified the control group as being the person who eats an average amount of fruits and vegetables. So here, exercise cuts the risk of catching colds. Independent variable? If you answered exercise, that's correct. What's the dependent variable? If you answered risk of catching colds, that's also correct. What's our experimental group? The people doing exercise. And what's one possible control group? If you answered people who get an average amount of exercise, or people who don't go out of their way, or people who don't who aren't trying to do exercise with that in mind, then that would also be correct. So there's two possible answers there. People who have used cell phones for at least 10 years have a greater chance of developing a rare brain tumor. I hope that's not true. Um, what's our independent variable here? Yeah, cell phone use over a period of 10 years. What's the dependent variable? If you answered brain tumor, that's correct. Experimental group, that's the people using the cell phone. And one possible control group, somebody who hasn't used a cell phone over the past 10 years. So here are a lot of great extensions that you can go look at for some extra things that you can find on the Science Vault. I hope this was helpful for you guys. And if you have any questions, we'll see you in our Google Meet. Write down those questions and have them ready to go. And we'll see you then. Thanks, guys.